Thank you. So, thank you, and good afternoon. So this work, my talk today is work done and in progress with two of the organizers, Alessio Chilo and Jana Zillman. And I'll focus on exemplifying how the use of Bayesian networks in climate storylines would be useful. So, so first, laying out a bit of context. This work is done as part of the RECEIT project, which is an EU Horizon 2020 project, which explores how remote climate events outside Europe would impact Europe. And we try to answer this through the use of climate storylines, which I'll come back to in the next slide. The project focuses on several sectors, which you see on the screen, and storylines are constructed for each of these sectors. And what I'm working on within this project is on the synthesis of risks based on the analysis of the individual storylines and connecting them to policy recommendations. And in doing so, a method we have decided to use, which is the main topic of today's talk, is applying Bayesian networks to these climate storylines. So I brought up two concepts here, climate storylines and Bayesian networks. So I first like to go briefly through these two concepts and then show you an example of how Bayesian networks are applied to climate storylines. So first, what is a climate storyline? As we define it, it is a physically self-consistent unfolding of past events or of plausible future events or pathways. So in essence, it's a narrative of a historical event, say flood or drought in the past, or a realization of the same event in a possible future climate, say under a higher temperature or higher sea level. And since this is what we're considering as an actual event that happened and was experienced by stakeholders and policymakers, it leads to greater engagement with those stakeholders and hence higher policy relevance. So that is one reason why we would like to use the storyline approach. And the storyline approach complements a risk-based approach where probabilities of a specific type of event is assigned probabilities based on downscaling from, say, global climate models. In contrast, in the storyline approach, probabilities aren't necessarily assigned to the events, but rather we do the analysis conditional on the specific event and consider what would happen conditioned on what the event happening. So in that sense, it complements a probabilistic risk-based approach. And what we want to do is to apply Bayesian networks to climate storylines. So what are Bayesian networks? They are directed acyclic graphs like the one you see on the screen, which represent conditional dependencies. They're constructed to show causal relationships within the system. And as the name suggests, they can incorporate probabilistic information based on data or beliefs. This is then through expert analysis. So one reason we want to use this, the reason that Bayesian networks are compatible with the storyline approach is in its conditioning nature. So we can think of elements within the system and add it to the Bayesian network in a modular form, and we can condition on a specific element within the Bayesian network as we like. And so that directly corresponds to the conditioning nature of the storyline on conditioning on the specific effect. So in that way, a Bayesian network becomes a powerful interface for exploring storylines when we embed a storyline into a Bayesian network. And we'll see an example right after this, but this includes investigation of possible policy options, which becomes important in thinking about systemic risk. One thing to note is that the use of Bayesian networks itself in environmental risk analysis is not anything new, but what I want to exemplify here is how it becomes a powerful tool in thinking about systemic risk and policy options within this context of storylines. Okay, so with these in mind, I'd like to go to a specific example of storylines, and that the storyline is about the EU Solidarity Fund and tropical cyclones. So tropical cyclones generally don't directly affect Europe, but the EU nations have islands in the Caribbean or Indian Ocean, and those can be directly damaged by tropical cyclones. Now, The European Union Solidarity Fund is an emergency fund that pays out in cases of damages caused in European nations. So when damage is caused in these EU outermost islands, then the Solidarity Fund must pay out. And what we're interested in is whether the EU Solidarity Fund capital stays positive, so that it could pay out in certain storylines. Now, in constructing a specific storyline, we consider multiple cyclones from 2017 and 2018 and think of their downward counterfactuals. That is, what could have happened to the individual cyclones in the worst case scenario. And this is done using past forecasts of the individual cyclones and damage estimate simulations done through the Klimada model. So here, what we're trying to construct, the storyline we're trying to construct corresponds to a specific set of cyclones that are chosen. So we have 13 cyclones to consider in total, and a specific set of cyclones would correspond to one storyline. And so we want to embed that storyline into a Bayesian network framework. So I'll show you the Bayesian network in the next slide, but briefly going through what we did is we first create a causal network corresponding to the storyline. And here we enable conditioning on certain sets of cyclone, which corresponds to the storyline. So in that way, we can embed the storyline within the Bayesian network. And second, we assign conditional probabilities that come from the simulated downward counterfactuals. And these results change depending on the climate or socioeconomic assumptions we make, and also on the policy assumption we make. In this case, we consider capital increase to the EU Solidarity Fund. So we put into the Bayesian network nodes so that we could condition on these different socioeconomic and climate or policy assumptions. And that creates the Bayesian network. And using that, we can ask the Bayesian network whether the fund would stay positive in a given storyline. So that's what we want to get in the end. Okay, a Bayesian network for the storyline I just outlined would look like this. So here, 5 cyclones are chosen as a set within the storyline. And the left-hand side shows the first year we're considering, and this right-hand side shows the second year we're considering. So just a bit more annotation. We have the cyclones corresponding to the 2 years. The ones we didn't choose are grayed out. And we also have climate, socioeconomic, and policy assumptions that affect how the effects of the cyclones propagate through the network into the remaining capital in a given year. So this kind of Bayesian network is what we're creating for a storyline. And since different users would be interested in different storylines, we decided to create a user interface for the storyline using the Bayesian network framework. So on the left-hand side dashboard, a user can choose the specific set of cyclones that they want to consider, and that shows up in the Bayesian network on the right. So here, 5 cyclones show up in black, and so that gives the Bayesian network. And the user can also input assumptions regarding socioeconomic assumptions of the future or climate change, how climate change would occur here. That would correspond to GDP increase and the intensity increase of the cyclone, and that is given as a probability, or given by the user as a probability distribution. And most crucially, the user could choose a specific policy option they would take that would affect the results. So here it's the capital increase of the EU Solidarity Fund. And by choosing this and asking the Bayesian network what would happen, it would answer whether the EU Solidarity Fund would remain positive under the given scenarios. And here, a probability distribution is given where the red part corresponds to the fund going negative in the end. Okay, so this is one example of how the Bayesian network could be used with a storyline to explore how the results would change under specific socioeconomic and climate assumptions and depending on the policy options taken. Okay, so for the rest of my talk, I would like to go through another aspect of the Bayesian network for the use of the Bayesian network framework, and that is the synthesis of multiple storylines. And using the Bayesian network, this can be done intuitively by connecting the nodes within each storyline. And by doing so, we can explore and identify the systemic effects that would occur between storylines, say compound events or cascading. In doing so, we added one additional layer of classification following a classification presented in Zeitler et al., a review on compound events, where they classify climate events into modulators, drivers, hazards, and impacts. And in addition to that, we add policy intervention nodes, which becomes important in the storylines, and also a possible climate scenarios node, an overarching scenarios node. So if we color the nodes depending on the classification. So the EU Solidarity Fund storyline Bayesian network would look like this after coloring according to the classifications. But the true power of the classification comes in when we're thinking of multiple storylines and integrating. So this is integration in progress of the research project storylines. And here you could see that we're grouping the nodes with the same in the same classification, so which have similar aspects. And by doing so, we can connect the nodes downstream together to connect the storylines and look at the systemic effects that could occur between storylines, and also think of possible policy interventions in green that could enter at any point within this whole picture. Okay, that's all I have. So I went through the Bayesian network framework and how it's applied to storylines, and that allows us to make probabilistic predictions based on user needs, and it connects to policy options and recommendations. And also the systematic classification allows us to synthesize the storylines and creates a possibility of exploring systemic effects in the system. That's all. Thank you.